Oh, it didn't say recording in progress. All right. How's everyone doing? Are there any questions before we begin? I did indeed yesterday. It was getting a little out of hand, so I was like, why not? So, as many of you know, your exam is next Thursday. It shouldn't be that bad, I would assume. That's if you study at least. Today we'll cover, I'll finish going over the problem we did last time. Then I'll look at an example from your homework. Let's see what else. And then I'll start 7.2. And that's where it will end for exam 2. Yeah. I have a little topic review sheet that I'll go through and write some stuff out about it. So last time we talked about, where in the world? There it is. That's how it's going to be. We talked about confidence intervals. When is the exam? Next Thursday. Same room as always, and the same time. What? Oh, whoops. I guess that'll be cool enough. Let's see, what is the one that we were going through say that I rushed through? It says a university wishes to estimate the mean GPA of its undergraduate students. A staff member randomly selects 45 undergraduates and finds their mean GPA to be 2.56. If the population standard deviation is assumed to be 0.52, calculate a 98% confidence interval for the mean GPA of all undergraduate students. First thing you want to identify in the problem is what is N. So that's the sample size. In that case, we sampled 45 students. Next thing you want to identify is what is the point estimate. So in this case, it's X bar, and it was 2.56. Then it says we know the population standard deviation sigma is 0.52, and we know the confidence level is 98%. The first step that I go through is find the point estimate. So that's what PE means, point estimate. In this case, we're trying to create a confidence interval for the population mean. So our point estimate will be the sample mean, which is 2.56. The second part is find the critical value. How do you do that? So first you need to find alpha. So set up 98% equals 100 times 1 minus alpha percent. Divide the 100% on both sides to get 0.98 equals 1 minus alpha. Then what must alpha be for that one? 1 minus 0.98 is what? Yeah, so alpha is 0.02. And whenever we look at the critical value, here we have the distribution of the z-scores. And we have some lower critical value here. Oops, that was awful. We have some lower boundary here and upper boundary here. So here is your negative z alpha over 2. And here is your positive z alpha over 2. And the area in the middle is 1 minus alpha, or 0.98. Then the area in these two tails added together will give you the value of alpha, 0.02. Then there is alpha over 2 area in each tail. Then all you need to do is find a z-score such that the probability of getting a z-score less than or equal to this negative z alpha over 2 is equal to alpha over 2 which is 0.01. Everyone okay up there? Then the next thing you want to do is find that z-score in the table. And if you do that, you end up with, so the closest to 0.01 without going over it is, where is it? 0.0099, and that's at negative 2.33. So this implies that negative z alpha over 2 is negative 2.33. Or you can just say that the positive and the negative z alpha over 2 is plus or minus 2.33. I don't care if you just give me the positive one on the exam. What's the next step? Holy cow, we're running out of room. 3, calculate the standard error. And remember, the standard error can be found by sigma over the square root of n. You're given sigma, you're given n, so then it's just 0.52 divided by the square root of 45. You can round that or not. I just didn't round it in this case. Then part 4 is calculate the margin of error. You do that by taking the critical value you found in part 2 and multiplying it by the standard error in part 3. So it just looks like z alpha over 2 times sigma over the square root of n. That would be 2.33 times 0.52 over the square root of 45. And the last step is get the confidence interval. Someone said something in the chat. What they say? At the top, what are the letters that equal 98%? This right here, 100. Oh, this CL, that means confidence level. Then the last step is, I'll just write it over here. Give the confidence interval. What does that look like? It's just X bar plus or minus the margin of error in this case. Then all you would do is take 2.56 plus or minus this. And if you do that, you get the interval. What is it? 2.38 to 2.74. That's not a 7.
The Turkish made by Rockdar TV2 is pretty impressive. For comparison, it can stay on station.
And we'll talk about interpreting that here in a second. So it's actually the next thing. So you should probably know how to interpret it. It will probably be on the exam in some form or fashion. So what does this confidence interval say about the population mean GPA? We are 98% confident that the mean GPA of all OSU undergrads is between the lower limit of 2.38 and the upper limit 2.74. Then if you want to change this statement for like any scenario, you can say we are a certain percent confidence, so that would be the degree of confidence you want. Then if you're doing a confidence level for the mean, then you're whatever mean you're interested in. So in this case, we're interested in the mean GPA of all OSU undergraduates, and is between the lower limit here and the upper limit here. Any questions over that one? Cool. Now let's take one from your homework. This is question 5. And why do I do it like in those 5 steps? Why do you think? It makes it a little easier to kind of determine the order that you're going in. And that's how I put it on the exam. So that's why I do it in class. Question 5, a random sample of 50 cars in the drive-through of a popular fast food restaurant revealed an average bill of $16.64. Will you lecture? Oh, yes, I forgot to do that the other day. Sorry, I'll do that. I forgot to post the Zoom lecture on Canvas and on YouTube, so we'll do that today. It says a random sample of 50 cars in the drive-through of a popular fast food restaurant revealed an average bill of $16.64 per car. Holy cow, who in the world and where are you buying your fast food? The population standard deviation is $5.31. Estimate the mean bill for all cars from the drive-through with 94% confidence. And reading that off, we know that N is the number of cars sampled, which is 50. The next thing you want to identify is what is the point estimate in this case. So the point estimate was the average bill price per car. And in this case, it was $16.64. So X bar equals, you don't have to put the dollar sign, 1664. It says the population standard deviation, so that is sigma, is equal to $5.31. Says estimate the mean bill for all cars from the drive-through with 94% confidence. That implies the confidence level is 94%. We will use that in a second to find the critical value. The first part, the point estimate. What is the point estimate in this case, since we're estimating the population mean? The sample mean, X bar, which we wrote down was $16.64. Now the second part, find the critical value. Can anyone tell me what the value of alpha for that will be, just off the top of your head? Yeah, 0.06. So that means the area in between some negative z-score and some positive z-score. This area will be 0.94. And the area in the two tails added together will give you 0.06. Then the area in each tail is 0.06 over 2, or 0.03. Then you look at the area to the left of this, and you can find this corresponding z-score in the table. And if you do that, the probability of z being less than or equal to negative z alpha over 2 is equal to 0.03. I don't know what that one is. I'll look it up. 0.03. Where the heck is it? The closest without going over it is negative 1.89. I'm gonna have to check that because your homework sometimes takes the upper one for some reason, and I don't know why. Because the book specifically says take the lower one. You want to know another way to find this thing? I'm I'm gonna go to the thing over here. It's on the calculator. The other way is this. Go to second vars. That takes you into the distribution tables. Then go to inverse norm, number 3. Tell it the area. So it defaults if you have an 83 to the area to the left. Then you want to enter in the area to the left of this negative Z alpha over 2. So just put 0.03. Tell it the mean and standard deviation. In this case, we're dealing with Z scores. So the mean is 0. The standard deviation is 1. And then just hit paste. And it will tell you what it is. It says negative 1.88079. Did I read the wrong thing? I may have. Negative 1.8. Yeah, I did. What the? That's weird. It's so close because on your table it says 0.0301. Let's take that one. As your homework probably will take it. Yeah. Like how you find it. Go second vars, then to inverse, oops, not that yet, inverse norm. Then inside that, put the area to the left as the first thing, the mean, and the standard deviation. If you have an 83, it'll make you enter the commas, or if you have an older 84, it will make you enter the commas. Everyone okay with how I did that on the calculator? If you don't have one of those calculators, I'll have like 3 or 4 for the exam. And if you need help trying to find it, just let me know during the exam. Then we're going to use negative 1.88 because that's what the calculator is saying. That implies that positive and negative Z alpha over 2 is equal to positive and negative 1.88. Part 3, calculate the standard error. That's sigma divided by the square root of n. So that's 5.31 divided by the square root of 50. I have no idea what that is. Round it to 2 decimal places. Is it 2 or 3? Yeah, let's round it to 3. 0.751. The next part, calculate the margin of error. So that's take part 2, the Z-score you get, and multiply it by the answer in part 3. That would be 1.88 times this right here, 0.7. Oops, thank you. That's about, oops, not that. That's about, gosh dang it. Here, that's the bad part about doing it in 2 different places, you forget. I have no idea what that is. Let's again round it to 3 decimal places. 1.88 times 0.751. 1.412. And the final step, take the first part plus or minus the last part. That's X bar plus or minus the margin of error. So that's 1664 plus or minus. Since this is actually in dollars, we're going to take it to the second decimal place. So it'd be 1.41. Let's see what this interval gives us. 16.64 minus 1.41. 1523 is the lower one.
What?
1805. Let's see if that's what it says in the solutions. If it doesn't, then we use the wrong z-score. Where in the world is it? What number is this? 5. And hot doing, we got it right. Everyone okay with that? So if you're uncertain about what z-score it should be, use your calculator. And whatever the 2 decimal places it is, use that.
Okay. No. No.
Everyone okay with that? Now, the next thing we'll talk about is the sample size needed to achieve some margin of error. Now, oops, make sure that's on. Recall that our margin of error formula, so I'm just going to call it E in this case, because I think that's what your exam or your solutions use in the guided solution. So E, the margin of error, is equal to the critical value, Z alpha over 2 times the standard error, which is sigma over the square root of n. Now, what we're going to do here is try to figure out the minimum sample size needed to achieve some margin of error. The first thing it says, if the sample size increases, then we expect the margin of error to decrease. Why? If I keep this critical value the same and this population standard deviation the same, as I increase n, this fraction here does what? It gets smaller and smaller. Therefore, this term is getting smaller and smaller. So as I increase the sample size, the margin of error and standard error will decrease. That means it makes a smaller confidence interval. What do you think would be another way to make a smaller confidence interval? If I keep these two the same, and I want to keep some error, I want that error to be small. So what must my Z alpha over 2 be? Smaller, right? That means as the confidence level goes down, the interval gets narrower. As I go up in the confidence level, the Z alpha over 2 gets larger. So my confidence interval becomes more wide. And that should make sense. If we want to be certain to a higher degree of confidence that some parameter is going to lie in some interval, then our interval must be a little bit wider to accommodate for that certainty. That makes sense. Cool. Then, what do we want to do? We're given E, we're given the confidence level, and we're given the standard deviation, and we want to solve for n. How do you do that? The easiest way is to just isolate n. Do you want me to show you the derivation or to show you the formula? I don't care. You don't need to know the derivation. Okay, the formula is n equals Z alpha over 2 times sigma divided by E squared. How do you do that? Invert this. I don't guess you have to. I guess you could invert this on both sides. Then you get 1 over E is equal to square root of n over Z alpha over 2 sigma multiplied by Z alpha over 2 on both sides. That gives you Z alpha over 2 times sigma over E is equal to the square root of n. And then you square both sides to get that. Cool, easy enough. And in here, Z alpha over 2 is obviously the critical value. Sigma is the population standard deviation. And E is the given margin of error. what happens if whenever I do this calculation, n comes out to be a decimal? What do you think I should do? So if n is a decimal, I can't really sample a half of someone. So in that case, to achieve that margin of error, I should round it up. If n is a decimal, round up. No matter how small of a decimal it is. Now let's look at an example that does this. A scientist wishes to examine the average depth of a river. He wants to be 99% confident that the estimate is accurate within 2 feet. From a previous study, the population standard deviation is 4.33 feet. How many measurements should be taken? We're just going to use this formula here. All that we need to identify is Z alpha over 2, E, and sigma. What does it already tell you in the problem? It tells you 2 pieces already. You want to be accurate within 2 feet. So 2 feet is E. So E, we can just say it's 2. We don't have to write the units. What is sigma? Yeah. It literally says sigma is 4.33. And the only thing you need to find is Z alpha over 2. We actually have found this one before because the confidence level is 99%. We found it last time. And what was that Z alpha over 2 value? So I need to show you how I did that. Let's draw it out again. So you have the distribution of the z-scores here. You have some negative z-score here and a positive one here. And the area in the middle is 1 minus alpha, so 0.99. Then you have 0.01 left to distribute within each of the tails. If you go up here to this, go down here to this lower tail, the area to the left of this will be alpha over 2 or 0.05. Wait, that's not, wait, 0.005. And you look for a z-score such that the probability of z being less than or equal to this negative z alpha over 2 is equal to 0.005. And the closest one that does that is a negative 2.58. So if you just look at the positive one, it's positive 2.58. Everyone think they could find those? You should probably know how to do something like that. Hint. Then plugging those in here, n is equal to z alpha over 2 was 2.58. What was the next one? Sigma is, where's that? 4.33. And E is 2. Then square it. If you do that, someone tell me what you get. Yeah, 32. So if you do it, it'll be 31.2. Then since it's a decimal, round up to 32, not 33, 32. Everyone okay? What's up? Yeah, this thing, right, where was it at? Here? All you do want me to like do how I did it here? So all we did, we derived this from this thing here. We use this. In this case, we're given E and we can find these, or we're given sigma and then we can find this. So then you solve for this and you get that. Do I need to show you how to do that? And then you just use this formula to plug it in here. Then using that, you use the critical value, which goes here. Then you use the population standard deviation, which goes here. And then you use the error that you want to be within. Does that make sense? Let's see, is there one like that on your homework? There should be. I don't know, is there? Here's one. Trying to see if we do this in the next section or not. Do we? Okay, we don't. Cool. Let's look at number, what is it? 21. It says a pizza shop owner wishes to be 99% wishes to find the 99% confidence interval of the true mean cost of a large plain pizza. Why would you want plain? How large should the sample be if she wishes to be accurate within 16 cents? A previous study showed that the standard deviation of the price was 24 cents. In this case, the confidence level is 99, so this will stay the same. E will change and sigma will change. It says we want to be accurate within 16 cents, so E is 0.16. It says the standard deviation was 24 cents before, so 0.24. And it said 99% confidence. So it's again that Z alpha over 2 of 2.58. Then just plugging these in here, we have Z alpha over 2 is 2.58. Sigma was 0.24. And E was 0.16. And if you plug that in, you get, let's see. $14.97. I guess you could say 98. So round up to N is 15. And let's see, is that correct? That was number 21. Obviously, you're not going to get the same exact numbers as what I get up here because Alex will automatically give you different numbers. And yes, the answer was 15. Everyone okay with that part right there? Now this next part. We're doing a confidence interval for the population mean, but in this case, you don't know the population standard deviation sigma. And this is what we talked about in 7.2. It says in practice, the population standard deviation is usually not known. Obviously, if you can't sample all the people in the population, you're probably not going to know the population standard deviation. Now we need to consider a way to estimate sigma, and what is the easy way to do that? So if we have a sample, you can obviously estimate what from that sample? S, and you can use that to estimate sigma. However, we we'll need to use a different critical value in this case because we don't know sigma, so we can't use the critical z values. That's what it says. And this, what does this mean? We can no longer use z alpha over 2 in our confidence interval whenever we use S to estimate sigma. Then the distribution we use is the next thing it talks about, the student's t distribution. It talks about 2 properties of it. It says the first, it's bell-shaped. T distribution is bell-shaped. And what is the second one? The distribution approaches the standard normal. Approaches the standard normal as we increase the sample size. You can say as n increases. Then it gives you a little picture there, and it shows you how the standard normal distribution relates to whenever you have the sample size is smaller than 30, and when it's close to 30, and you can see as it's getting larger and larger, it's getting closer and closer to the normal distribution, which is the blue curve. Oh my Lord, there's more properties of this. Lovely. Okay, let's talk about them, I guess. I don't know if these are on your homework or not. But first, we just talked about it. It's bell-shaped. But you may need to know them for the exam. Who knows? I know, but you don't. 2, symmetric about the mean. Third, mean equals the median equals the mode. And what do you think that is all equal to? Any guesses? Just like the z distribution, it's equal to 0. And they're all in the center. And then the last one, since it's a continuous distribution, the curve will never touch the x-axis. You can say touches or crosses the x-axis. Now, those are all properties of the standard normal distribution that apply to this one. However, there are 3 different differences. The first, if you look at the actual shape on the previous page, what do you notice about the t distribution in comparison to the z? It's obviously more spread out. That implies, for the first thing, the variance and standard deviation are, what do you think? Greater than 1. If they're going to approach the standard normal distribution, obviously that standard deviation and variance is getting smaller and smaller, and it's getting closer to 1. The second one, we already talked about this. It's, where is it at? It's actually this one right here. As n increases, you can say without limit. That just means as the sample size gets larger and larger and goes to infinity, the t distribution approaches the standard normal. And that's number 2. And then number 3, as you can tell by the previous page, obviously the shape of the distribution is dependent on, so we're just going to say this goes here. And number 3, it's based on sample size. Obviously, you can tell that from the previous page. Now we're going to talk about something known as the degrees of freedom. This is what we will use to find a corresponding critical value using the t-distribution. Then, what is the definition of degrees of freedom? So I'm just going to say DOF. It is the number. Everyone okay with I use hashtag? Okay, cool. The number of values that are free to vary after a statistic. Does it say sample statistic? Yeah, it says sample statistic, so sample should be right here. After a sample statistic is computed. Then the next question says, what does this mean? I'll show you what it means. It's a lot easier to do that. As an example, let's take the mean of 5 values and let the mean be 10. So I have n equals 5 and x bar equals 10. Remember that x bar is the sum of the data values, the sum of the xi's divided by the corresponding sample size of n. And that would just be x1 plus x2 plus x3 plus x4 plus x5. You can just multiply by n, you get nx bar. What this is saying, if I know what this is equal to, so n times x bar, this is equal to 50. How many numbers in here do I need to know if I can, in order to find the last one? So there's 5 unknowns. I have something that it's equal to. How many of these unknowns do I need to know to solve for the other? You need 4. So if I give you all 4 of these values here, you know the sum, you can just subtract it over here to find the 5th. In that case, the degrees of freedom is 4. In general, the degrees of freedom, so the sample size was 5, and we took off 1 of them. So in general, the degrees of freedom is equal to n minus 1. And n in this case is what? N is the sample size. In this case, yes, it was 5. Does everyone understand kind of why that is? If I know 4 of these values and I know what it's equal to, I can solve for the 5th. Then using the same idea to create the confidence interval. Let's erase this. In the last part, we had that the confidence interval basic formula was equal to a point estimate plus or minus a margin of error, right? And in the last section, our point estimate was the sample mean X bar, and the margin of error was Z alpha over 2 times sigma over the square root of n. So if I say I can't use the Z distribution anymore, and we're talking about the T distribution, you're obviously going to use a critical T value. And that implies the point estimate will still be the sample mean X bar. The critical value you use in this case, instead of a Z alpha over 2, will be a critical T alpha over 2. And since you don't know sigma, you're going to estimate it with what? S, and then divide that by the square root of n. That is the 100 times 1 minus alpha % confidence interval whenever you don't know sigma. You could also write it as this. I think I wrote it in here like that. X bar minus T alpha over 2 times S over the square root of n. Mu is in between the lower limit and the upper limit. Some of your homework questions have it formatted like that. So that way could be helpful to remember as well. Right here? Yeah, so this is X bar plus or minus T alpha over 2 times S over the square root of n is less than mu. So it's basically saying mu is in between these two values. And that T alpha over 2 is determined by what? So it has area to the left of alpha over 2, and it has degrees of freedom equal to n minus 1. So T alpha over 2 is the critical values that correspond to alpha over 2 probability and degrees of freedom. So another shorthand is df of n minus 1. Then it talks about an assumption. So in order to calculate the confidence interval, you must assume the sample is random or the population is normally distributed, or the sample size is greater than or equal to 30. And then you can say about the central limit theorem, the distribution of the sample means will be approximately normal. Now, how in the world do you find the critical T values? They're actually easier to find than the critical Z values. If you look on page, what is it? I think it's 9. Page 9 of your distribution tables packet. I'll put it on the document camera. So here at the top, it says confidence intervals, and it has the confidence level. Obviously, most of the time I'll tell you the confidence level, so you can just look at that. If I tell you the value of alpha, in this case, you're doing a two-tailed, because there's two tails still of the interval, because you have the middle, there's a left area and a right area. So it's called two tails. In chapter 8, we'll talk about one tail, which is whenever we do hypothesis testing, and it's the probability of something being less than something or greater than something. In this case, we're doing something that's called not equals. Then you go to whatever that value of alpha is for your two tails, or you can just look at the confidence interval level. If I give you that, then you intersect it with the corresponding degrees of freedom, and it tells you the positive critical value. Easy enough. Then the first one says, what is T alpha over 2 for 99% confidence interval when n is 10? So it tells you the confidence level. Just go to 99 over here on the right-hand side. Go down to the degrees of freedom is equal to 10 minus 1, which is 9. And if you intersect those two, you get 3.250. And that is how you would find it. Do you want me to show you how to find it on the calculator as well? Doing that, it's kind of like how we did earlier. You'll go second, vars, then you'll go to inverse t. You enter the area to the left. You enter the mean, and you enter the standard deviation. Wait, no, you don't do that. You enter the area to the left, and then the sample size minus 1, so the degrees of freedom. If I remember right. Inverse t, you order the area. So in this case, it automatically takes the area to the left. In this case, we're doing 99% confidence, so the area to the left of the negative critical value is what? Alpha is 0.01, alpha over 2 is 0.005. So that is the area to the left. So the degrees of freedom, 10 minus 1 is 9. Hit paste, negative 3.2498. So if you're round to 2 decimal places, negative 3.25. So that implies that just the positive one is positive 3.25. You could. I mean, if I say find the critical value on the exam, you don't have to put both. You can just put the positive one. I don't care. Either one. I know what you mean if you get the right critical value. The next one. What is T alpha over 2 for 90% confidence and n equals 18? Does anyone have their table and want to tell me what it is? Yep, correct. You look at 90% confidence. The sample size is 18, so the degrees of freedom is 17. Intersect those two, and you get 1.740. You could also do what we did on the calculator here. In this case, the area to the left would be what? If it's 90% confidence, alpha is what? Yeah, alpha over 2 is 0.05, yeah. Alpha is 0.1. So the area to the left of the negative critical value is 0.05. And the degrees of freedom in this case is 17. Where in the world is there? It is. And if you do that, negative 1.7396, if you round that to 2 decimal places, negative 1.74, which implies the positive one is obviously positive 1.74. Everyone okay? What's up? You can do it on the 83. Oh, it doesn't? Okay. Yeah, then just use the table. Yeah.
The 0.050, you got it from 90.
So 0.05 is, so this is the confidence level, 90%, right? That's equal to 100 times 1 minus alpha percent. So remember, whenever we're dealing with confidence intervals, so in this case, we're dealing with the t distribution. There's going to be a negative critical value and a positive one, right? And the area in the middle is the confidence level as a decimal, so 0.9. Then that means that area 0.1 is remaining in these two tails added together. So there's 0.05 in this one. So I'm just telling you the default area to the left. That's where at the 0.05. I did not know the TI-83 did not have it. Yeah, just use the table. You'll get the same thing. Obviously, I won't give you a degrees of freedom that isn't in the table. I'll have to check your homework and make sure it doesn't though. Now let's look at an example to do this. It says a random sample of 10 children. Oops, I need to turn the camera around. Oh, there's only 12 people online. People slacking. If they ain't watching this, it's their own fault. They may see something like this in the exam, who knows? A random sample of 10 children found that their average growth for the first year was 9.8 inches. Assume the variable is normally distributed and the sample standard deviation is 0.96. Find the 90% confidence interval for the population mean growth during this year. I don't know what the growth is about. I'm assuming about a baby. I don't know. No idea. Doesn't give any context. So in that case, n is 10. What is X bar? Yeah, X bar is 9.8, so the average growth for the first year. What else do we know? Yeah, so S, you know that is equal to 0.96. And I tell you the confidence level is 95%. The first step is find the point estimate. So in this case, we're estimating the population mean. We'll estimate that by the sample mean, which is 9.8. The second part is find the critical value. In this case, we're looking at a 95% confidence interval with degrees of freedom of what? 9. So intersect 95 and 9 on the table, and you should get 2.262. So intersect 95% confidence intervals. So that's what it says at the top. And degrees of freedom is equal to 10 minus 1 or 9. And that will give you the critical t value. So it just gives you the positive ones is equal to 2.262. Does everyone want me to show you how I did that on the table or not? Okay, all you do is intersect those two. The third step, calculate the standard error. So in this case, it's not sigma over the square root of n, it's s over the square root of n. And s was 0.96. Divide that by the square root of n, which is the square root of 10. If you do that, well, I didn't write that down, so just leave it as that. Part 4. Then calculate the margin of error. So that's the critical value in part 2 times the standard error in part 3. So that would be 2.262 times 0.96 divided by the square root of 10. If you give it this way on the exam to me, that is fine. If you do it as a decimal, that is also fine. Then the final step is give the confidence interval. So take the point estimate plus or minus the margin of error. That would be 9.8 plus or minus this right here, 2.262 times 0.96 over the square root of 10. If you're doing this in your calculator at one step, make sure you put parentheses around that. Now, someone tell me what you get as the lower limit and what as the upper limit. Someone besides Grace. Yep, 9.11 is the lower one. And what is the upper? Yep, correct. Then using this confidence interval here and this level, then you want to make an interpretation. So we will say this. We are 95% confident. That's not how you spell confident. Or 95% confident that the mean population growth so POP is short for population is between the lower limit of 9.11 and the upper limit of 10.49. Make sure you know how to interpret the confidence interval you get. It will for sure be on the exam in some way. Also, I'd recommend on knowing how to do the confidence interval. I can't remember how much it is worth, but it's worth quite a bit. Would you like to know how much it's worth? Let's see. Holy cow. 4, 8, 12, 20. Sort of the fifth of the exam. Okay, it'll be basically the same idea as the last one. 5 true and false, 5 multiple choice. There's 4 questions that are easy. I've kind of talked about what you should do, but I'll talk about it next time in particular. And then there is 1, 2, 3, 4 total free response questions with different parts on each. As long as you pay attention during the review on Tuesday, you'll be fine. As of now, no. I'll figure something out maybe. I don't know how many points I'm allowed to give out up to, how many points is this class worth total? 700. So I can give up to 35 bonus points total. I can give 5% basically. Everyone okay with that problem? Neat. Let's do one from your homework. Oh, your chapter 7 homework won't be due for a while because we're not going to finish it. I could start 7.3, but that'd be too much. Let's look here. That's not that. Here, let's look at It's 98 on there. Yes, it is. Let's look at number 13 on your homework. You want me to show you how I do it usually instead of the 5-step way? It's a lot quicker. Well, it is to me at least because I've done it before. Okay, the problem says a meteorologist who sampled 10 thunderstorms found that the average speed at which they traveled across a certain state was 18 miles per hour. The standard deviation of the sample was 3.7 miles per hour. Find the 98% confidence interval for the mean. Assume it's normally distributed and blah, 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 blah. I guess I'll go over the blah, blah, blah part in the part 2 of the question. First part says find a 98% confidence interval for the mean. The easiest way I find to write it down if you're not doing the 5-step method, but the 5-step method is what I put on your exam. That way it makes it easier for you to do. But if you don't, first, Sample size, 10. Second, point estimate. In this case, X bar is basically the average speed at which the thunderstorm travels through the state, and that is given to be 18 miles per hour. Then it says the standard deviation of the sample. Key words, of the sample. That implies that S is what we're looking at, and that's equal to 3.7. Then it says we want to be 98% confident. Confidence level is 98%. Since we know S, you're going to have to use a critical T. If you use a critical T with 98% confidence and 9 degrees of freedom, what do you get? Anyone? Let's go. Oh, no, not that one. Another one. 98% confidence, intersect it with 9 degrees of freedom, 2.821. This implies that T alpha over 2 is equal to 2.821. So you have all the stuff you need now. Write down the formula for the confidence interval X bar plus or minus T alpha over 2 times S over the square root of N. You have all the numbers here, just plug them in. X bar is 18 plus or minus T alpha over 2 is 2.821. S is 3.7. N is 10. If you do this, the lower limits is Has anyone else got the lower limit? That should be the upper one. Wait, what? Oh, yep, you're probably right. I did 18 instead of 4. I did 10 instead of 18. I was looking at the sample size. What'd you say? 14 point what? Yeah. So if you, how many decimal places does it say in round 2? Round intermediate and final to 2. So it'd be 14.70 is the lower one. And the upper one is I'm just scrolling back to hit plus 21.30. Oh, I need to turn around the board. Oopsies. All I did was plug those in to here. Easy peasy, right? Let's see. You don't want to go over another one that's on your homework? Okay, let's look at number 11. Is it okay if I do this same way? It's a little bit quicker. What's up? Yes. Whenever you're dealing with a sample standard deviation, you use a T. If you're dealing with the population standard deviation, you use the Z. Okay, so let's quickly look through this question 11. It says a random sample of 18 registered nurses in a large hospital showed that they worked on average 44.7 hours per week. That is a lot of hours. The standard deviation of the sample was 2.5. Estimate the mean of the population with 99% confidence. Just reading off the parts, the sample size was 18. Number of hours worked on average is 44.7. Implies that X bar is 44.7. The standard deviation of the sample is 2.5. And the confidence level is 99. what was the, okay. So in this case, it'll be a different critical value. So you need to intersect 17 with 99% confidence intervals. And if you do that, you get what? You get 2.898. Then just plug it into here. That would be 44.7 plus or minus T alpha over 2, 2.898 times S 2.5 divided by the square root of n, which is 18. This gives you an interval of I don't know what. 44.7 minus 2.898 times 2.5 over the square root of 18. The lower limit is 42.99. And the upper limit is 46.41. How would I interpret that if I asked you to? In this case, it would be, we are 99% confident the average number of hours worked per week for, I'm just going to say RN for registered nurse, is between the lower limit of 42.99 and the upper limit of 46.41. Everyone okay with that interpretation? Okay. We will review on Tuesday for your exam, and then we will have obviously your exam on Thursday. Have a good day.